Okay, I think I'm going to begin now. So welcome to part 5 of my webinar series on the Vault API. This one is going to be talking about events, the event feature that we put in for Vault 2012, and how you can use these events to customize the Vault business logic. So my name's Doug Redmond. I'm a programmer on the Vault team, and I'm kind of I fill the role of API expert for the Vault developers. So that's a bit about me. I also have a blog which is focused only on Vault API stuff. So I'm going to be referencing the blog frequently because that's a great spot for me to post things and get feedback and try things out. So moving on, talk a bit about this webinar series. So it's a 5-part series. This is the last part. Part 1 was just kind of a high-level overview of everything, no real technical details. And then parts 2 through 5, the idea is I drill down on specific topics and show sample code and things like that. So it started out kind of basic, and then for part 4, it was a bit more of a complex topic. You talk about the job queue and things like that. And then here, for this session, it's going to be talking about event-based programming, which is just a complicated topic. So I consider this an advanced skill level class. Just to get this question out of the way, yes, I'm recording this session, and I will be posting this session, and all the sessions are recorded, and I'll be posting all of those. So the way I do it is I wait till the end of the series, and then I post everything. So once I complete this, hope either today or tomorrow, I'll have all of the videos up on my blog. So that's where you can find them. Again, my blog is called It's All Just Ones and Zeros. You can get to it from this URL. You can also get to it from the autodesk.com page. There's a blog section, and it lists all of our blogs, and I'm listed there. And not only am I going to be posting the recording of this, I'm going to post the slides, I'm going to post any sample code. Pretty much everything that I show will be posted. So an overview of this class. So my goal for this class is to kind of explain how you can customize features through this event mechanism that we put in place. There's 4 types of events mainly that that we have for Vault. I'm going to be going over each one of those. And then I'm going to kind of go over like the best practices and ways you can kind of maximize your usage of these things. The requirements for the class, I'm going to assume you know what Vault is and what its features are. And like I said before, this is an advanced class. I've really geared it toward professional programmers. If you're kind of a hobbyist programmer, you might find this a bit over your head. One other thing I should mention, if you were at Autodesk University in Las Vegas a couple months ago, and you attended my class there on events, then you don't need to be here for this webinar. I'm going to go over the exact same, it's the exact same class basically. Unfortunately, they didn't record my AU session, which is why I'm doing this webinar and recording the webinar. So so the content is exactly the same as my AU class. Anyway, if you're not a professional programmer, you're welcome to stay. You're just going to find some of these topics a bit challenging. So here's going to be kind of the structure of this webinar. I'm going to talk a bit about each of the 4 types of events that we have in isolation, talk about what they do, how they work, what all of the rules are, and then after that I'm going to go into some of the best practices. So common errors that you want to make sure to avoid, and some techniques, and then I've got a bit of a case study to go over that illustrates a lot of these points. Q&A will be done at the end. If you have a question at any time, feel free to type it in the questions box, and then I'll get to them at the end of the slide deck. Okay, so I'm going to start by kind of showing an example, and I'll switch to my video here. Okay, so you should be seeing something playing in Windows Media Player right now. And what's being shown is this application I wrote that's up on my blog. The application is called VaultHeart Bluestreak. And if you don't know what Bluestreak is, it's something that's up on Autodesk Labs. It's kind of, the idea is to kind of take some social media principles and apply them to CAD design. So the idea is, and Bluestreak is cloud-based, so you and a bunch of other companies, if you're working on an architecture project, for example, you can all collaborate through Bluestreak. And it's got this thing called an activity stream where you can kind of get updates from people on what they're doing. And, Bluestreak also has like users and groups and messages and kind of a file repository. So a lot of things like that. So someone had suggested that I write a connector between Vault and Bluestreak. So that's kind of what you're seeing up here. And the idea is that from Vault, you log into Bluestreak, and then as you do things in Vault, it's going to update Bluestreak's activity stream. So in this example here, right now I'm creating a change order, and then I'm going to change the state on it. And then if you go to the activity stream, you see that change order has changed state. And so this is kind of what the user sees. And what's going on behind the scenes is I've got a bunch of events that are triggering. And those events are synchronizing the data with Bluestreak. So from the user's point of view, they don't really see anything happening. There's no UI. It's all a bunch of stuff going on in the background that synchronizes this data. So that's kind of an example of events in action. And I'm going to go more deeply into this example later. But that's kind of the idea. That's at least one thing you can do with events. Okay, so back to my slide deck. Okay, so I mentioned we've got 4 different types of events, and they have long names. I apologize for that. But one thing I kind of want to make clear is that each type is very different from the other types. They all have their own set of rules. They all have their own way of working. They have their own advantages and disadvantages. And one of the things I want to make sure is that you guys know all of this stuff so that you can choose the right tool for the job. Now, unfortunately, the concepts can all kind of muddle together, so I'm going to try to clear everybody's mind when I switch from one type to the other. So I'm going to talk about one, and then I'm going to try to clear your mind for the next one. I think this worked okay when I did it live at AU. I'm not sure if I'm going to be able to clear your mind as well through a webinar, but I'll try it, and we'll see how it goes. Okay, so I'm going to start by talking about Webservice Command events. This is kind of the most complex one, and I think this is the one that most people think about when they think about events, at least in terms of Vault. Now I should start by mentioning that all of these event features are not available in base Vault. You need to have Vault Workgroup, Collaboration, or Professional. And in all of these cases, you're basically plugging in to various Vault components. So again, we're talking about DLLs that you write in .NET. And when your code runs, you again have the freedom to do anything that a DLL can do. The only thing is that UI in certain cases is a bad idea. If you don't know for sure that you're running inside of an app that supports UI, then you don't want to be popping up dialogues or something like that. But other than that, you have a lot of freedom for what you can do. And because it's .NET, you've got your choice of language. Now, since this is an advanced class, I'm only going to be showing C# code. In the past, I did VB.NET because those were kind of more basic classes. But here we're hardcore, so it's going to be C# all the way. Okay, so when we're talking about Webservice Command events, the idea is that you basically get to hook to any Vault application that's running on a given computer. So here's my diagram that I like to show of all of these different Vault pieces. And the part in red is the part that we're going to be customizing with this event type. So as I show, you can basically hook into everything. Let me talk a bit about this and try to explain why we came up with the name that we did. So hopefully you know about our web services set of APIs, right? Those let you talk to the server, and that's in this case, this is where you're going to be hooking into. The events are going to fire at the web service level. So what we've done is the web services are composed of a bunch of functions, right? And we've kind of inferred a concept that we're going to call a command, which is just going to be a grouping of functions that basically do the same thing. So one example is if you want to add a folder, there's two functions that will do that for you. There's add folder and add folder with category. In terms of an event hook, you just kind of want to hook into the add folder command. You don't really care which function was called. You just care that a folder is being added and you want to hook into that. So that's kind of how we came up with this name of a web service command. You create your hook, you hook it into this add folder hook, and then you'll get called when either add folder is called or add folder with categories is called. You as an event programmer don't really have to care which function got called. But that's kind of the basic idea is that you're kind of at more of an abstract level. So we're basically giving you the idea to hook to these groups of functions, and you can't really hook to everything in the web service API because there's hundreds of things that you can do. We decided only to focus on some of the major actions that people want to do. So for example, things like checkout. We've got events for that because we know that a lot of people want to hook in at that point. But if it's something like, get folder by name, there's no event hook for that. So we've kind of done it based on need. And in the future, we can certainly add more hooks as people have need for more stuff and feedback is appreciated. But that's kind of the idea is we kind of took the major operations and we put hooks on those. So here's a chart that kind of shows what actions you can have hooks for. And I kind of broke it up by feature and by entity. So like for add, you've got a bunch of hooks for there. Adding files, folders, items, change orders, you have hooks. Same with delete. Reserve for update, that basically means you're locking down the entity for an edit. So in files, this is called a checkout. And then for items and change orders, there's a different word for it, but the concept's the same. We've got hooks for the commit, which is like the check-in for files. And lifecycle state change is another thing we've got hooks for. And then some things don't really fit on the chart, but we still have hooks for them. So download is a hook, and promote item is a hook. And in case you don't know, what I mean by promote is you're taking a file and you're running like the assign item command from it. You're building a set of items based on a file or set of files, and that's what I mean by promote. So there's a hook for that. So these things are triggered by somebody making a call through our web services API. The way we architected it is that each function is going to fire only one event at maximum. There's a couple of corner cases where technically you can do multiple operations with a single function. So checkout file is a good example. You can actually do a download through a checkout file. In that case, you're going to get the checkout event, but you're not going to get a download event. Anyway, if you want to see the full mapping between what functions fire which events, that's in the SDK documentation. It's in the knowledge base. There's a page called Webservice Command Event Mappings, and that shows you the full mapping. So the intent of this thing, right, is that you write your event hooks, you deploy it. Again, you're deploying it to program folders. If you've seen parts 3 and 4, I've kind of gone through those steps where you deploy your DLL to something in program data, Autodesk, Vault 2012 extensions. You put it there, you get your vset config file. You put all that in place, and then you're basically hooked into every Vault client on that computer. That's the theory anyway. What actually is happening is anything that's using Autodesk Connectivity Web Services is gonna let you hook into it. If there's like a Java client or something that's talking to these web services directly via HTTP and they're not using the .NET libraries, then you're not going to get events for those. So it's not 100%. However, if we're talking about the Autodesk products, they all use this DLL. The only one that doesn't is 3D Studio Max, and I have yet to find a person who's really doing Vault development with Max. But I felt I should mention it anyway. But everything else, AutoCAD, Inventor, Revit, Publisher, they all use this web services DLL to communicate. So they'll all fire events that you can hook into. Also, if a third party develops their own client, we encourage people to use this DLL. Not only is it much easier to use, but again, it's going to be tied into this whole event framework. So you can even tie into applications that weren't provided by Autodesk. And I mentioned before, this is a client-based system. Hopefully, if you've been through all of my my sessions, you'll have noticed a pattern, which is that customization is client-side always. There's no way to customize the server. There's no way to get your code to execute inside of database operations or anything like that. So the same is true for event type stuff. If you want events to be fired from all of your Vault users, you're going to have to deploy your plugin on every computer that's using Vault. And unfortunately, that's just the way it's architected. So let me go through the timeline for what happens during these calls that fire events. There's actually going to be 3 events that can be fired for an operation. The first one is called get restrictions, and that allows people to basically block the operation. And that's really all it's supposed to do is it'll go to anybody who's hooked to it, and it'll say, okay, we're doing this operation, here are the parameters. Is it okay to continue with this operation? And if you're plugged into that, you can say no. I don't want to go through with this. So for example, let's say we're adding a file, and you don't like the file name inside of your code. You want to enforce a very strict file naming policy. With an event hook, you can check the name, and then you can say, no, I don't like this name, and then you're going to basically log a restriction, and that's going to halt the operation. So that's how you're expected to kind of block something. Okay, so after get restrictions, if everybody's okay with the operation, it's going to move to the pre. And the purpose of the pre is for you to do whatever work you want to do before the operation happens. So that's the point of the pre. Once the pre is complete, it's going to go actually make the call to the server. And then when the server returns, it's going to send out the post event. And the post event is going to go out even if the server has an error. There's still going to be a post event. So that's kind of the timeline here. Let me just kind of show it a bit more just to drive the point home. So the application is going to make some sort of web service call. Maybe it's add file, for example. So they call add file. The framework is going to go through and fire off the get restrictions event to anybody who has subscribed to it, who has said, okay, I want to get restriction, or I want to subscribe to the get restrictions event on add file. So anybody who's subscribed, they'll get a notification and they'll get a chance to block it. If nobody's blocking it, it's going to go to the pre. And again, anybody who is subscribed to the pre-event for add file will get a notification and they can do whatever work they want to do. Then it's going to go to the server. Server's going to return a result. And then the post event's going to go out to anybody who's subscribed to it. And then each event handler can do its own work. And then after all of that is completed, then the hosting app gets control again. So from the parent application, it looks like it just called add file, and that's all it really knows about. But it just under the hood, all of these event notifications have gone out and things like that. So that's kind of the timeline and the workflow here. So, okay, how it works. If you want to hook to everybody on a computer, on a given computer, what you do is you're gonna implement an interface, the web service extension interface. You're going to follow all the rules that extensions have to do. You have to have your assembly attributes set up. You're going to have a a vset config file. You're going to have to deploy it all to the program data extensions folder, just like with a custom command or a custom job handler. And then at runtime, your DLL is going to get loaded into the various Vault applications. The Vault framework will basically create a new object for your web service extension, and then it's going to call onload right after it loads it in. And the expectation is in that onload event, that's when you can put in your event subscriptions. So here's what the code looks like. Hopefully you can all read this, but again, I'll be posting the slides if you can't. So there is an onload. So here's my class. Here's my I'm extending iWeb service extension. The only thing in that interface is this onload function. That's the only thing you have to fill in. And in this case, I want to get restrictions for add and delete folders. So I've hooked those things specifically, and these are static event hooks, which means I don't have to create a new object. I can just go to Document Service, and then I hit dot, and then I can bring up these add folder events, which is kind of the collection of the three, the pre, the post, and the get restrictions. And then I can then select my my get restrictions, and I'm going to hook to that very specific thing. So that's kind of what I'm showing here is the two event hooks. And then, of course, inside of each of those handlers, that's when you would actually run the code that you want to run. So inside the handlers, follows the typical pattern for events. You get your sender object, and you get event args. Depending on the operation you're hooking to, the event args are going to be different, but basically the event args is going to tell you what's being passed in or be passed out if it's a post event. So this is where you can figure out, okay, what's the name of this folder, where are they adding it to, where are they deleting it from, those type of things you can all get from the event args. So here's kind of a visual representation of what's going on here, right? You've got in this little dotted box, that's your on your Windows folder, that's where you're placing your DLL. And then these kind of brown boxes, those are running applications, and those will basically load in your DLL and create your extension object. So if by any chance you're running AutoCAD, Revit, and Vault Explorer at the same time, you're going to have your extension is going to get created 3 times, one for each application. Now, you know that's how you that's what it looks like if you want to hook into every application on a computer. However, there's kind of another way of doing it, which is let's say you just want to hook into AutoCAD. You just want to do things when AutoCAD adds in a file, and you don't really care about any other application. Well, that's perfectly allowed, but the steps are a bit different. So all of that stuff I talked about with the iWebService extension, you don't need to do that. You don't need to deploy it to your extensions folder. What you would do in this case is you would write an AutoCAD plugin, a .NET plugin, whatever those steps are. I've never done that for AutoCAD, but you know, you write your plugin that way, and I believe AutoCAD has some type of onload concept, right? There's code that lets you know that your application or your plugin is loaded, and inside of there you can hook in to your Webservice Command events from the Vault code. And then once you do that, basically what it looks like is inside of AutoCAD you've got your code running, but in any other application it's not going to have your code running. So now you might think that this setup is better, right, where you're plugging into everything, right? Intuitively you think that you'd always want to do that, but actually I found in reality you usually want the other case. You usually want to only plug into some, you know, a specific product or a specific set of products. So what I've done is I've actually kind of created a little chart here that kind of explains the pros and cons of each approach. I'll just run through this real quick. So let's say we want to do something that's really customized to AutoCAD drawings. It's probably best if we do something very specific and hook only into AutoCAD. That way we know a bit more about what the data is. We know a bit more about what's going on inside of AutoCAD. We can do things like say, well, what document is open? That's something we can do if we hook in only to AutoCAD, but we can't do if we're going to hook into everybody, right? UI is another one of these things where if you're just doing this kind of generic thing that hooks into everybody, well, you don't know if you can have UI or not, right? It might be a command line app that you've hooked into, or a service or something. But if you've written your AutoCAD plugin, you know it's running in AutoCAD, and you know you can pop up whatever dialogues you want. So again, you get a bit more freedom there. If you want to do kind of like strict rule enforcement, gatekeeper type stuff, that lends itself a bit more to the first approach, where you're hooking into everybody. Same if you're doing something really low level. But if you want to do something a bit more high level, where you know about the context of what the user is doing, then again, it's better if you're specific to one specific application. And that Vault Heart Bluestreak app is a good example of that, in the sense that because I'm running inside of Vault Explorer, I know more information about what the user is actually doing, and I'll illustrate that a bit later. But anyway, my recommendation is when you start whatever your project is, and you're thinking about what to hook into, I would suggest to first consider the single app approach. Can I just get away with hooking into AutoCAD, or just hooking into only Vault Explorer, and maybe kind of exhaust that possibility first. And only if that way doesn't really do what you want it to do, then you can then go plan for this approach where you hook into all applications. Okay, quiz time. Again, hopefully you can see this all, but what we're going to do now is we're going to play a game called What's Wrong with This Code? And I'm going to talk through what this thing does as well. So what we have is we have a handler for a check-in event. This is a post event. So this is going to get called right after something gets checked in, right after a file gets checked in. And what I want to do with this thing is I want to create a log of all of the check-ins that go on in Vault. Just a simple text file, and each time a check-in goes through, I just want to add a line to the text file that says, okay, this file's been checked in. And I've decided that I'll keep this log inside of Vault, because it's a nice centralized file repository. So what this does is, okay, so I get my event, I start up my web service manager, and I get the file object for the file that's been checked in. Then I go to my log file, and in this sample I just hard-coded it. It's called log.txt. It's in the root folder. I'm going to grab that file. I'm going to open it up. I'm actually going to check out my log file. I'm going to convert it to string. That's what all that UTF encoding is. I'm getting the string representation of that file. I'm adding a new line of text at the bottom, and then I'm going to convert it back to binary. I'm going to check in my log file. So that's what this thing does. So I ask you, what's wrong with this code? Feel free to shout it out, but I'm probably not going to hear you. I'll just give you a minute to think about it. Oh, there we go. Okay, hopefully you came up with the right answer, which was that you're going to run into an infinite loop. Because what we're doing is when we update the log file, we do a checkout and a check-in. When we do the check-in of the log file, that's going to trigger a post event, which is going to loop back to the beginning of our code where it says, oh, a file's been checked in. And then we're going to log that change again. And then when we log it, we check in a file, which is going to fire the check-in event, and it's just going to loop around like that. And I actually have a video that I'm going to show, because it's fun to watch videos of Vault crashing. So let me switch over to my video here. So here I've got my Vault, I've got my log. I don't have my log file yet. what I'm going to do is I'm just going to edit a text file, just a random file. I've checked it out. I'm going to make a change to it, and I'm going to check it in. So my event handler is in place. I do my check-in, and I've got the little window that says checking in file, and it's just going to sit there. Vault Explorer is pretty much locked up at this point. So let's try to see what's going on here. So I'm going to start up a second instance of Vault Explorer so that we can see what's happening. So okay, so I've got here's my root folder, there's my log.txt, and hopefully you can see the number of versions is at 299 right now. I do a refresh, now the number of versions is at 308. Do one more refresh, now it's at 315. So log.txt is just constantly updating more and more versions in an infinite loop. So, okay, let's go back to our original instance and try to cancel that check-in dialog. Well, nope, that didn't work. The cancel button isn't going to save us. It's still going. We're at 456 versions now of log.txt. So, okay, how do we fix this here? The only way to really do that is we have to go to the task manager and kill the process. So I'm going to go in. I've got two clients running. I kill the one with the higher memory consumption. And that is what breaks us out of the loop, is killing the process. And we're at 565 versions of log.txt. So that happened all within a minute or so. And if we open up log.txt, you'll see that the first line is the info, the original file we edited, and then every other line is just log file logging the fact that log file has changed. So infinite loop, something to avoid. But the quiz isn't over. We're going to keep playing this game. I'm going to go back to the code. I'm going to insert an if statement to fix that loop. So I put in something that says, okay, if the file that's been checked in is named log.txt, exit. Don't do anything. So that way, log.txt is not going to log itself changing anymore. We're only going to log different files that have changed. So I still ask you, what's wrong with this code? Still a big problem here, or at least a potential big problem. You have to kind of think out of the box too, but I'll give you a couple minutes to think of what the problem might be. Okay, the answer is alone, on its own, if your plugin is the only plugin, then things work fine. However, maybe somebody else has another plugin that's running on the system, and their plugin works the same as yours. It's basically this log file that logs anytime a file's been checked in. But instead of naming it login.txt, they've named it checkinlog.txt. But other than that, all of the code is the same, and they also have an if check to make sure that they don't infinite loop on their own. So what we have basically is, in isolation, each plugin works fine, but when you put the two together, it locks up Vault again. And again, I've got a video of that. So here I've got my check-in log, I've got my log.txt, they're both at version 1. I'm going to go to my info text again, and I'm just going to make some random edit to the file. Going to check it in. And now we've locked up again. Same pattern as before. And nope, cancel buttons doesn't help us either. So what's going on under the hood is that each plugin is logging the change from the other plugin. So it's just going, it's still an infinite loop, but it's going back and forth between two different event handlers. So again, the only way to fix it is to kill the process. So I'm going to do that right now, and then I'm going to kind of, I'll open it up again and kind of show you the aftermath. So we've got check-in log, it's at version 111, the other one's at version 112. If we take a look at the contents of it, check-in log has a bunch of text saying that log.txt has changed. And then if you go to log.txt, it's going to show the opposite. It's going to show all of the changes that that the other log file did. So we basically bounced back and forth. So yeah, as you can imagine, that one's a fun one to debug if you get into a situation like that, because it's not just about a single thing failing, it's about multiple things working together to fail. So what's the takeaway from this? How do you avoid this? Couple of suggestions. Probably the best one, the most bulletproof, is that inside of an event handler, don't do anything that could trigger an event. That'll guarantee that this doesn't happen, but it's limiting, right? Because most of the really good stuff will fire an event. So, you know, adding files, checking in, checking out, download, all of those things fire events. So if you go just by the best practice, that means, you know, you can't do any of those operations inside your event handler. So can be kind of a downer. So I came up with a couple of other ways that might work in your situation. One is to just keep a Boolean around that lets you know if you're in the middle of an event handler. That way, if so you and that's what the code is I'm showing in that white box is, okay, so we've got my check-in file event. I've got a Boolean called processing, and if that Boolean's true, I'm just going to exit. I'm not going to do anything. It's false by default. Once I start running, I'm going to set that Boolean to true. I'm going to do a bunch of stuff, and then when I'm done, I switch the Boolean back to false. So in the middle of my try block, if I do something that triggers an event and that eventually gets back into my code, I've got my Boolean that will prevent me from doing anything, and that'll break out of this infinite loop. So that's one way. Another way is to just maintain a tight control over what's running on your vault. Obviously, this only applies if it's your vault, right? If you're customizing something for your company and you're doing it that way, then you have that level of control. But if you're like a consultant or something, that's a bit harder to pull off. Another way is job server might be a good workaround. So inside of your event handler, you queue up a job, and the job, when that job runs, that job will do the actual work. And another part of this thing is that whatever machine's running job processor, that's not going to have event handlers on it. In other words, job processor basically gets to do things without triggering events. So couple of options on the table. I'm not saying any of them are perfect. It kind of depends on your situation. Okay, one more thing I just kind of want to mention about that example that I gave. Just in case somebody came up with this answer, I want to give them extra credit. if you're doing like a rolling log file, you don't want to use a check-in, check-out system to do that, because I mean, there's hundreds of transactions. You don't want to keep checking in, checking out stuff. So rolling log files, they don't really mix well with the check-in, check-out system. So that's all I wanted to say on that. Obviously I chose that just because it made a good example. I'm not saying it's something you would want to do in the real world. Okay, that's it for my overview of web service command events. So at this section, please just clear your mind of everything so that we can start fresh with the new stuff. And oh, hey, look, kittens. Oh, look at the cute kittens. What were we talking about again? I don't remember. Okay, I guess we'll just move on then. Web service invoke events. So a bit of how things work under the hood. Basically, all of the web service calls get funneled through a single choke point called, and it's a function called invoke. And that's how we kind of came up with this name. So what we did is we basically put pre and post events around this invoke command, so that you kind of have a choke point that will let you hook into every web service call. This isn't just for things like check-in and check-out and adds and deletes. I'm talking about every call, the get calls, the the finds and the gets and whatever. So this gives you kind of complete control over everything in all of your web service calls. And I underlined the word your. Right. The thing about this is you can hook this into your own code, but there's no way for you to hook it into somebody else's code. So like if you're plugging into AutoCAD or something, you can't hook into the AutoCAD vault operations this way. These event types are meant for you in your own code to help manage your own projects. Another nice thing about this is you can actually edit the data going in and out. The other event types don't let you do that. This one does. So if a function's being called and you want to change the input parameter from a.dwig to b.dwig, you can do that here. Same with the output. If the return value is something you don't like, you can actually just return a different value. So the idea is you've got your you've got your code, you've got your web services, and you can basically put hooks into that. So why is this useful? Why do we put that in? Well, it's nice to have a single choke point for everything. So you can do things like common error handling. You can even fix errors in certain cases if you want to log stuff and do debugging. It's very useful for things like that. So back to my little architecture diagram, when we're talking about these type of events, we're talking about custom applications only. So something you've written and you want to hook into your own code, you've got that hook point. So here's the timeline, pretty basic. Again, this is revolving around a web service API call. So before the call, you get a pre, the call gets made to the server, and then afterward, you get a post. And you'll still get a post even if the server returns an error. A bit of historical background. The main motivation for this thing is the fact that in the early days of Vault, you would have to generate your own web service objects yourself through Visual Studio, and that let you directly hook right in to these this choke point, this invoke command. And then once we moved to this DLL approach where everything's pre-generated for you, we wanted to make sure you still had that choke point, because at least I found it was very useful to have it. So I made sure that we kept it in. So that's kind of the reason we put it in is to kind of support these this feature that had been there in the early days. So here's actually an example of how it's used in the Web Service Manager. This thing's built in by default, but the way we did it is we used these Invoke events. So I think I mentioned in some of my other sessions that if a client is inactive for 30 minutes or basically the server doesn't get any API calls from this client for 30 minutes, the server is going to assume that the client's inactive and is going to free up the license. And what this means is when the next time that client goes to make a web service call, it's going to get error 300, which basically means that the token is invalid, the security token. So the way to fix that is what you want to do is you want to re-authenticate, get a new security token, and then you want to rerun whatever the command is that failed with error 300. You want to run that again with the same parameters, and then that's your result. So this invoke, these invoke hooks were perfect for that. We did a post hook, checked for error 300. If we found that we had error 300, we would basically log in again and then run that exact same command again and then pass up whatever result came back from the second run. And you know, when it all comes together, it's great because the client has no idea that this happened, or not the client, but whatever the application was that made that call. Maybe it's something simple like get folder by path or something. The executing code has no idea that this error 300 ever happened. It's all cleaned up by the event hooks. Okay, so here's kind of what it looks like. Here's some code for how you would hook into these event types. So once you have your object set up, and in this case I'm using the Web Service Manager. So I've created a new manager. I go to my document service object and I say, okay, I want to do event hooks on this object. And then you do these post invoke events, and then you have your handler, and then that's what you do. And then inside of your handler, this thing will get called for every document service call on that object. We'll now go through this handler. And the code I'm showing here is I'm just writing to a log file all of my document service calls. And if things succeeded, I'm just going to write out the name of the function. But if an error happened, I'm gonna print out the full exception trace. So all of that's going to go into the trace log. And let me switch to video real quick so I can show you what this looks like. So in this case, I hooked that code into my vault list sample. And all this does is it lists every file in the vault, and I've got a pretty small vault here. So after it runs, I go to my log file, which is under C:\tracelog, and then there's the output. It's just a list of all of the document service functions that were called. So that's that code I showed you. That's what that does when you execute it. So quick video. Okay, so that's really it for this event type. I don't have much more to say. So we're done with this. So once again, please clear your mind. And to help with that, I'd like you to take a look at this picture and try to figure out what's going on. I've looked at this thing for months. I can't figure it out. Anyway. So after staring at that for a while, that should really do a good job just clearing out whatever else it was you were thinking about. However, we don't want to stare at this thing too long. I'm afraid it might do permanent damage. So let's move on. Next event type, Vault Explorer command events. So I talked about this a bit in part 3. When you do an extension into Vault Explorer, like a custom command or something, one of the things you can do actually is you can hook in and get events whenever any command is run inside of Vault Explorer. Not just your commands, but if somebody clicks on the refresh button or somebody clicks on the copy design command, or maybe it's like through a context menu, they select copy design, you're going to get basically a pre and a post for that. And you don't get much information in your pre and post. You basically get the name of the command, and not the display name either, like there's an internal name for it. So yeah, you'll get notifications of those. If you've got custom commands, you're going to get notification of your custom commands. You'll still get the execute event, but you'll get a separate pre and post for that, and same with any other custom commands from other people. You get pre and post of that. So on its own, it doesn't tell you much. It basically says, okay, the user clicked on this command, something happened, now the command's done with, and you don't really know what happened in between. So back to my architecture diagram, the point we're hooking in here is specifically Vault Explorer. That's the only context in which this type of hook makes any sense. The timeline's pretty straightforward. You've got the pre, you've got the command, and you've got the post. Now the command itself, you know, it might be simple, it might be complex, right? So, and there may or may not be UI. So if you do something like the copy hyperlink command, there's not even any UI for that. It copies stuff to the clipboard, and then you go on to the post event. If you're doing something that has a dialogue in it, like copy design, you get your pre, and then the dialogue pops up. The user does whatever it is they do, and then once that dialogue closes, then that's when you get the post event. And the post event's still going to fire even if there was an error with the command or the user canceled the command or something. You're still going to get a post event. So it's kind of how that works. So here's what it looks like if you're hooking to this in code. So probably a good place to hook in would be during startup. So you've got your iExplorer interface, you've got your onStartup function. Usually I leave that blank, but if I'm hooking to commands, you can hook in there. So you get your application object, and on it you've got a hook for command begin and command end. So I've hooked to both of those, and then all I'm doing in my handlers is I'm just going to do a message box that shows me this ID that is used to key off of what command got selected. So let me show you what it looks like when that code is actually executed. Switch over to Windows Media Player here. So just as I'm doing things, I'm getting these pop-ups all over the place, these annoying pop-ups that say pre-event, post-event. So let's see. So we'll do a get. We get the pre. I'm going to cancel out of it. I still get the post. I hit the refresh button. I get a pre. Everything refreshes, and I get a post. Pretty basic stuff. And that's it for my my web service invoke event. Or oh, sorry, that slide's titled wrong. It's the end of the Vault Explorer command event section. So for one last time, I'm going to ask you to clear your mind and I'd like to share something with you, just something I've been going over in my head. I feel that if RoboCop and MacGyver teamed up, that would be awesome. If you don't know what MacGyver is, it's a show that was on in the 80s. This guy MacGyver, he would, if he ever got into a situation, he could just take random junk and invent something with it and get him out of the situation. Like, you know, take a tube of cardboard and some ammonia and some duct tape, and he makes a bomb out of it and stuff. So anyways, I thought that if he teams up with MacGyver, that would just be really awesome. And I want you to think about that for a minute. Or maybe you've got your own team-ups that you think would be really cool. You can kind of think about that a bit and clear your mind that way. Okay, last type of event. And this is kind of a, it's kind of an honorary event type. This is basically a feature that I talked about in part 4, where you can put jobs on the job queue based on a lifecycle action. And you use the lifecycle event editor in the SDK, and you say, okay, anytime a file goes through this transition, I want this job to be put on the queue. You can do it with items and change orders as well. So, in terms of event or discussion on events, we can view that job as a post event, right? Because it gets triggered automatically when something changes lifecycle state. So it's a post event on a lifecycle state change. Now, we're talking job queue, of course, so it's asynchronous. You don't get to execute it right away, but it still counts as a event. So back to my architecture diagram, we've got our job processor here, and that's the part that's being hooked to, so to speak. And another video, because I like videos. You've seen this already kind of in part 4, if you were here for part 4. It's another quick video. I'm just going to the lifecycle event editor in the SDK. Selecting a transition on files. So I'm saying if I go from work in progress to released, this is the job type I want created. So you click OK on that, commit the changes, and you don't have anything yet. Job queue's empty. But I go to my file and I change its state from work in progress to released. That's going to trigger the job. Now if I go back to the job queue, it's going to show the job on the queue with my type that I created, the Autodesk XYZ. So that's kind of what I mean when I say it's a lifecycle event job. It's a job that's because of a lifecycle event. Okay. Okay, those are the 4 types, kind of laid out one by one. Now let's kind of put them all together and go over which things are good for what situations. So here's kind of a little handy chart that lists all 4 of them. And it talks about things like, well, what are the hook points and how do they behave? What are you plugging into? Things like that. I won't go over everything, but there are some important things I do want to point out. So if we're talking about the inline behavior, meaning does your handler halt the application? In other words, you're executing in line with all of the existing code. The answer is yes for all of the types except for the job type. In that case, things go on as normal, the job gets queued, and it gets handled asynchronously. So that's something unique about these lifecycle event jobs. Another thing that's unique about those is that the server triggers it for the jobs. In all other cases, it's kind of the Vault client is the one that's doing the triggering. A lifecycle event jobs is the only event type that has guaranteed delivery. And this is the main reason I've even included it in this this discussion. So let's say you have data that you need to keep synchronized just between Vault and, I don't know, cloud-based PLM system. So you want to make sure that everything that happens in Vault goes to this other system, and it has to be 100%. It's not acceptable to miss something. If I did it with any of the other event types, there's always a possibility that, like, I do my edit, and right before the event fires, right before I get my post event, the power goes out, and I've basically lost that action, right? The edit happened in Vault, but I didn't get my post event. The code didn't fire. So now my systems are out of sync and things are in a bad state, and it's very hard to detect that something went wrong and recover from that. So that's what's nice about the lifecycle event jobs, is that the job is queued up as part of the same database transaction that does the lifecycle state change. So either they both succeed or they both fail. If you get that job on the queue, that means that definitely the transition has taken place. Also, if things fail for whatever reason, be it power outage or whatever, the entire operation will roll back next time the power goes back on. So that's what I mean by guaranteed delivery. Let's see, a couple other ones that are unique. So in most of these event cases, you're an observer to the data that's being transferred. So like with the Webservice Command event, yeah, you can plug into the check-in event, and you can see the data that's being sent to the server, but you can't change it. You can't change the file name. All you can do is complain about it and block the operation, but you can't go in and say, okay, just make this file be this name. The only type that lets you do that is those Invoke events. So that's something unique about that event type. Let's see, on the bottom I talk a bit about big picture awareness versus task awareness. So what I say by big picture awareness is like what's the user actually trying to do? What's the operation? Is it a copy design, right? I see all these files being added in. Is it because copy design's going on, or is it because they just dragged and dropped a file, or what? For most of these event types, you don't really know that. You just know, that a file's being uploaded or something. But in the case of the Vault Explorer Command events, you do kind of get a big picture idea. You know what button the user clicked on. So that's nice, but it fails on the details. You don't know what actually happened, and the other event types are good at that, right? With the command events, you get to know the work being done, so to speak. You get to know about the uploads and the downloads and the check-ins, but they're out of context. So the reason I'm kind of pointing that out is hopefully you're starting to think that these guys can work in tandem. They can complement each other so that you basically get to have the best of both worlds. And I'm going to show that a bit in my case study, how you can use the different event types to kind of put together a nice picture of what's going on. But first, let me show you a nice complicated diagram. Because after all, this is the advanced class, right? You have to have complicated diagrams. So what I'm showing here is basically all of the event hooks that I've talked about so far, all 4 of them, all of the pre's and the posts, and kind of how they, where they fit on the timeline in relation to each other. So the blue arrows are the execution threads. that are going on at various times, right? So you've got users who are running Vault Explorer, you've got the server that's its own execution thread, and then maybe somewhere on the network you've got job processor running. So those are the three blue lines we're talking about here. And let's say in Vault Explorer, the user clicks on a command, you get your command pre, stuff happens, a web service call is made from Vault Explorer, so you get your invoke pre, you get your command. Oh, sorry, you get the command pre first, then you get the invoke pre, then it goes to the server. The server might decide to queue up a job if it's a lifecycle state change. Then it goes back to the result gets returned. Then you've got your invoke post, you've got your command post. Maybe Vault Explorer loops around a bit, makes some more calls. Once that's done, you get your Vault Explorer command post, and then operation, basically Vault Explorer gets control back from this execution thread. So the parts in white are all of the hook points, and the parts in orange are the parts that you don't control. Those are the parts that are built in and they happen, and you can't really hook to them. But the white parts are the hook point. And if a job got queued, when the server was executing, then sometime later on a different a different process, there's that hook point, the job handled hook point. So this ties it all together. If you want a diagram that shows everything, this is that diagram. A couple of things that you're going to run into when you do these event programs. Couple of odd behaviors you have to look out for. You have to keep in mind that the stuff you do in these event handlers, the parent application has no idea you're doing this stuff. It's all going in. You're kind of being sneaky, so to speak. You're going in under somebody else's nose, and you're changing things around maybe. So this might result in something weird. Now the most common is that like the status icon is going to be incorrect. So for example, let's say you want to add some properties of your own after a file gets added. So somebody adds in a file, you go in a post event and you modify that file basically. That's all good and great, but Vault Explorer doesn't know you did that. So when it displays on the grid, the status icon is going to have that icon that says that the file's out of date locally, and the user's going to be all confused. It'd be like, wait a minute, I just uploaded it. How could it be out of date? And that's because nobody knows that your code is running, really. So that's a fairly harmless behavior. Other ones that are a bit more extreme, sometimes you can get errors popping up, and in really bad cases you can actually crash the application if you're not careful. So those are things to look out for and hopefully avoid the bad ones anyway. Another thing you have to kind of realize is that okay, so you've got your event handlers and you're getting data passed in. That data might not be good data, right? Right? Just because you've hooked into something doesn't mean that the data is correct. And there's even some data I'm calling stupid data. And one example is for Vault Explorer, when it's adding a file, there's a parameter called file name, right? And you would expect that it passes in the name of the file, like a.dwig or something, and that's it. But what actually gets passed in is the full local path, c:project x17/drawing/a.dwig, for example. That whole thing gets passed in as the file name parameter, and the server doesn't do anything with it. I checked the server code. The server just trims off the path information. So it really serves no purpose. Maybe it did years ago and it's just left in the code for some reason. But you're going to see this in your event handler, and it's going to be really weird. So, unfortunately, there's as time goes on, that stuff will get cleaned up, but keep in mind that there's always the possibility that weird data like that gets passed through. And before events were in place, nobody really cared about it, but now with events, these type of issues are coming to light. Also, in a post event, it's kind of nice because you get to know whether an error happened or not. But in a pre-event, you have to consider that maybe this thing is going to fail, right? Maybe the data passed in isn't good. The user didn't fill out the text box right or something, and it's actually going to fail. So for that reason, pre-events are probably, in a lot of cases, they're not used. It's usually the post events that are better because that way you can wait until it's completed. You know it's completed successfully. Then you can do whatever it is you want to do. I'm low on time as usual, so I'll skip over most of this. This slide's pretty obvious. Don't crash the hosting app. If you've got exceptions that are thrown inside of your code, handle them. Don't let them bubble up, because who knows what's going to happen. In a lot of cases, the parent app responds by crashing. So try to keep all your exceptions self-contained, and don't hurt performance, of course. So this brings me to some techniques that I found are pretty useful. So multi-threading is a very good technique to use with these events. So if there's stuff that you want to do, don't do it in the main UI thread, because that's going to halt the program and the user's not really going to know why. A lot of times it's best to spawn another thread, do the work in the other thread. That way the user can keep going on his merry way. Another thing is, just because you've got your post event handler doesn't mean you actually have to do the code inside of the handler. Sometimes it's better to just make a note, okay, something happened, I'll get to it later. And so sometimes it's just you wait until the UI command is finished, or maybe queuing it up in job server is also another good way to kind of reserve it for later. Okay, don't feel that you need to just stick with one type of event. It's usually good to do multiple different event types and to kind of have them all work together, and I'll show this a bit more in a second. But they really complement each other pretty well. And the last thing I want to mention is it's usually best to do your work in bulk. So a good example is, let's say we want to send out an email when files get added. If you work with Vault, you probably know that a lot of times you upload files in batches, right? Like with Inventor, you can have assemblies with thousands of parts, which means you have thousands of files. They all get added at once. In this case, you don't want to send out, if there's 100 files, you don't want to send out 100 emails, right? You want to send out one email that lists the 100 files. So it's good in your handlers. Again, don't do everything right away. Just kind of record it, gather it up later, and then that's when you get to actually do your work. So I'm going to go back to that application I showed before, Vault Heart Bluestreak, and I use all of those techniques in that application. So when it comes to my communication with the Bluestreak server, I do that in a separate thread, because one thing I found, and this was during a demo to all of my managers and the Bluestreak team, I found that at the end of my demo, a Vault would just halt for no reason, and it would just lock up for about a minute, then I'd get control for a while and it would lock up again. The reason was because Bluestreak had some kind of weird behavior where it wouldn't respond to my requests, and my code was halting, waiting for the HTTP timeout, which is like a minute or 90 seconds or something like that by default. So that was halting my entire Vault Explorer application. So my solution was put that in a separate thread. That way, if the other server decides to be slow or not respond, the user can still do other things inside of Vault. Another thing that my application does, and it's shown kind of in the video, is when something happens, it doesn't do it right away. It kind of gathers everything up. And so if somebody multi-selects a bunch of items and changes the states at the same time, my code records both of those operations, and then when everything's done, it updates the activity stream saying that 2 items have been updated. I don't want to go to the activity stream and do 1 entry for each item, because that could spam everything if I've got a lot of items. I just want to give like a total. And that kind of feeds into these other points. I use multiple event types. So I use the web service events to know what actions are taking place. And I'm using the Vault Explorer command events to kind of know how to gather up all of these things together, right? I know that I want to record the actions, but how do I know when I'm done recording? And how do I know when I want to send it to Bluestreak? Well, I've got this command post event that lets me know, okay, the operation that the user did is complete now. So now I can go talk to Bluestreak and say, hey, Bluestreak, 5 things just changed. So that's kind of what I use that for. It's kind of a good boundary point while I'm making these collections. So here's kind of how the code is laid out. Now, unfortunately, Vault Heart Bluestreak, I didn't post the source code for that because the Bluestreak API is not an open API, so they didn't want me posting the source code. But what I will do is I'll share the code that relates to Vault, and I'll have that as part of the materials when I post this thing. I'll have the Vault side of things. So here's kind of what I call it a workflow, but because it's event-based, we really can't assume things are going to go in the order of 1, 2, 3, right? But here's kind of how I set up the code. So we've got the Vault Explorer startup. When that happens, that's when I'm going to set up some lists, and that's going to be how I record my changes. So I set that up at the beginning. I set up all my event hooks, and that's my startup routine. Okay, moving on to number 2. I've got hooks for post events. So when those things execute, when I know that a command, when I know that a web service call has been made that does a lifecycle state change, because that's what I'm keying off of in my example. If a lifecycle state change happens, then I notify Bluestreak, and I don't care about other operations. So I've got my web service hook. It tells me that, oh, a file has changed state or an item's changed state. What I do inside of that is I update my list. I go to my list and I add a new entry saying, okay, these files have changed. And that's all I do in my event hook. I don't actually talk to Bluestreak yet. Okay, so moving on to number 3, when the Vault Explorer command itself ends, that's when I'm going to look at my lists. I'm going to say, okay, did anything happen during when this command was run? Do I have anything in my lists? So I check all my lists, and if they're all empty, then I do nothing and I exit. But if there's something in there, then I'm going to create a worker thread. I'm going to tell the worker thread what changed, and then the worker thread, I'll trust that the worker thread does its thing. But inside of my post event handler, once I spawn that worker thread, then I can clear my own lists that's controlled by the main thread. I clear those lists, and then I'm done with my post event. And then the 4th thing here is the worker thread. That's going to be the part that actually does the work and talks to Bluestreak. So here's kind of what the code looks like. I think I'll skip most of the code. You can look at that on your own, but that shows all 4 of those parts. So here's the startup routine. I've got my my web service post event for when a web service call is made. This is one example. This is the file example. So all it does is it puts something in the list. I've got my Vault Explorer command post event where I check my lists and I spawn a new thread. I should also mention my thread gets its own web service manager even. I don't want to worry about thread collisions when I'm making API calls. and the thread gets its own copy of my lists. So once the thread is running, I'm free to clear out my the main lists. So a couple things I really like about this application. If Bluestreak decides to get weird on me, it doesn't affect the client application at all. Things run normally. The activity stream, if you see an entry on the activity stream, that has a direct corresponding to a single vault command. So if the activity stream says that 5 things have changed, I know that a single vault command was run and that single vault command did 5 changes. It's just, I don't know, I kind of like that. Another thing I kind of like to care that I think is neat is that I don't actually care what the command was that did the lifecycle updates. You know, it could have been a custom command, it could have been the update lifecycle command, it could have been some type of change order workflow. You know, I don't have to go through every Vault command and think to myself, okay, which commands change lifecycle states and which don't. I don't care about that at all. All I care about is command, you know, my commands exited and something's in my lists. That's all I care about. And I don't actually have to check which command ran. And then another thing I like is that this plugin has a custom command in it that will upload the file. That command has nothing to do with events. Again, I'm kind of able to mix and match a bunch of different concepts into one plugin. So the plugin, not only does it do all this event stuff, but it also has custom commands like I showed in part 3. So they all work together fine. I was kind of happy with the output. So I'm going to play the video again so that maybe you can kind of see how some of these concepts tie together. And while I'm doing that, I'll go ahead and answer questions, and you can type your questions in because that's the end of my presentation. So let me just switch over here to Windows Media Player. And I'll just play that on a loop, and while that's playing, I will answer your questions.